You continue to incorporate wireless charging with laptops now.
Well, that's not surprising. Except you got to be moving way more data. I'd be afraid, or way more electricity. I'd be afraid of like arcing or something. You know, somebody's wearing a wedding ring. uh, I mean, all these things are, we're going to look back in 20 years and these things are going to seem stupid.
Yeah.
It's like, oh, your laptop has a battery? It doesn't just work off, it pulls energy from the core of the earth. Okay, so for those of you who didn't notice, everybody in here should be in the hackathon. Teams are up. Make sure you go on to Slack and see who your team is. And anybody in orange here is a team lead. Several of those people are in this class. So make sure you are in contact with your team this week. So if you're a team lead, reach out to all of your members. If you are a member, reach out to your team lead. And hopefully between those two moves, everybody's talking to each other so you guys can start brainstorming ideas. So guidelines for the hackathon. If you're mobile, you must write a native application, either iOS or Android. You must use Google Firebase. You should not contain authentication, since that'll just eat up half your time, and all you have to show for it is a username and login that passes the username and password that logs in. You must capture some data from a form. So if you're managing your record collection or something like that, you would have some form on there that takes in the name of the record and year or something, that kind of stuff, and store it in the database. You must show that in your project somewhere as well. Must solve a real world problem-ish. And I'm going to provide starter projects for iOS and Android that already, actually for Android, it's going to work a little different. I was going to say I'm going to provide one that already talks to Firebase. To get your Android project talking to Firebase takes about 8 seconds. I'm going to provide you with a little video that shows you what those 8 seconds look like. It'll probably be like a 3-minute video. But I'll also provide you like some chunks of code that you drop into your project that will show you reads and writes. So you'll be able to pretty much instantly have a working Android application with Firebase. And I'll do the same thing with iOS. I suspect iOS, I haven't gone and looked at their new API for Firebase, but I suspect I'll be giving you a full project for iOS as your starting point, because it's less integrated into Xcode than it is into Android Studio.
I feel like everybody always has to do Android.
Well, I'll still provide both just in case. VR project must be written in Unity using SteamVR as the native VR library. Benefit of that now, I know last year we used VRTK. A couple problems with VRTK. One is that they shut down. It's still available. They have a kind of a final version released, but they're not supporting it anymore. They ran out of funding. They probably should have. It was a pretty good product. They probably should end up charging for it, but they didn't. So whatever. But SteamVR is currently like the way to go with any VR development. I know Oculus has their own API that you can use, and we used to integrate that into VRTK. But bottom line is SteamVR supports Vive, Rift, and all the Microsoft mixed reality headsets. So this one project will work for anything we have in the other room. Okay. And what I'll provide you is a starter project that already supports teleportation. So you're I already have that done. So you're in this room, you can teleport all around. There's a single spot teleportation. So you can go to this one very special spot and you're in front of this table that has balls and boxes and stuff. And you can grip them and throw them and toss them to the other hand and that kind of stuff. And then we have a couple of platforms in there where you can teleport up onto the platform and kind of climb through the air to get to places. So you'll kind of have a starting point for some of the, the basic VR concepts. You can focus more on your VR experience for the hackathon rather than those things. So project must support locomotion of some type. I'm providing you with teleportation. That's going to be the easiest way to do it. But if you decide that it makes more sense for you to do slide, where you kind of drive through the world or something like that, that's fine. You'll have to implement it or find somebody, find something online where it's already been implemented. And you also have to work with the hand controls, which I've also provided you a starting point for that. And I think the team leads for all the VR ones are all familiar with Unity, so they should already have a background in box colliders and that kind of stuff. For team leads, keep in mind that most of your team should be on Slack, but they don't necessarily always check Slack. So email them as well early on and then get them onto Slack so you can have create a private group for your team or something like that. But make sure you are in communication with your team as soon as possible. If you're you should already have communicated with your team by now if you're a team lead. So if you haven't, email everybody and try to get them. If you noticed, I put up the penalty assignment today, and it's a doozy. I think it's a really good one, though. Write a 12-page paper that confronts the challenge of learning to program from a biblical perspective. Consider the time, dedication, perseverance, failures, and successes one must endure to become a successful programmer. Whether you are just beginning this journey or are taking my description from one of your early lectures to heart, or perhaps you have taken the voyage and either succeeded or noticed your shortcomings and could formulate a plan to reach your goal, you have a story to tell. Select one or more Bible stories from the New Testament and draw parallels between them and the journey to programming proficiency. Consider struggles from figures in the Bible as they face a seemingly insurmountable challenge, yet persevere and succeeded. Compare and contrast those struggles with your own story during your journey to become a competent computer programmer. Where have you failed? Where have you succeeded? What are the next steps? 12 pages. Should be a good learning experience for folks. I think it actually is a good paper, but the hackathon will be a lot more fun. So that is the punchline.
There's no way to get in the hackathon anymore.
Huh?
There's no way to get in the hackathon.
There is not. 5 p.m. Friday was the deadline. You're not looking forward to this?
I'd rather skip the game.
Now, in fairness, when I said there's going to be a penalty assignment, I said it's not going to be fun.
I know.
Yeah, so I mean it's and the good news for you is it's worth 3 assignments. So if you skip it, that's 3 zeros.
I'm not gonna skip it.
So that's even better. It could be a life-changing paper for you.
Hey, call me out in front of my parents.
You didn't buy my breakfast. What am I supposed to do?
Just out of curiosity, I didn't make it to the hackathon last year, and I had to do an 8-page paper. Why did you add on 4 extra pages?
Paper was too short last year.
It was.
Yeah. Didn't take you 12 hours, did it?
No, but I worked really hard on it.
But not 12 hours.
Not 12 hours, no.
Too short.
Since I'm going to Concordia sponsored event, can I get a reduced paper?
We can make it 11 and a half pages. I don't know what to tell you. All right. Questions about hackathon-y stuff at all? Okay, so let's look at our homework stuff. We're in Adam, right?
Nope.
Oh, yeah.
We started out in Adam.
Yeah. All right. Do I have Cloud9 up here? You see, it bugs me on my Mac that I can't not have a password. I have to use the little fingerprint thing. But then, if the machine reboots or something, or you've been away from it too long, then it still makes you type in your password. It says it won't. Fingerprint's not good enough. And if you disable the fingerprint, it'll let you do that and have no password. But then pretty much every time you open the lid, it reminds you, we really recommend you set up a fingerprint now. And so that just bugs you to the point you just want to have the fingerprint. Okay, so as a starting point here, I'm going to go. So I think where we left this, so this is our chat server, right? So I'll leave that stuff open for now. So we did all this stuff last time, and at the end of class, we had a weird segmentation fault. And I pointed out that I thought the error was likely with the shared memory, but I actually don't think it is on Cloud 9 because you're not the super user on the system. Your program's not running with the correct privileges. So if we try to compile this guy, so this is GCC chat server.c compiles, but then if we go to run it, we get our, oh, we don't get it until we try to connect, right?
Yeah.
All right, so we type something, press enter. Am I in the wrong program here?
You have the line commented out.
Oh, thank you. All right, so this guy had its segmentation fault right off the bat. Now, what I'm going to do is I'm going to change the way I start this program. I'm going to type in sudo bat. Oh, it's just complaining about port 8080. That'll fall off in a few minutes, but let me just... because we didn't gracefully disconnect from the port. You said we should be able to do different ports like that. Oh, thank you. Oh, it's not. It's on port 912, 9012 now. All right, so there's from the client. So it's able to receive the stuff. Now will the server receive that? Are we outputting? But in any case, you see the shared memory issue is we needed to have super user privileges in order to write to that shared memory. And that's how Cloud 9 is set up. And if you were on Slack yesterday, you would have seen that message go across. You're doing it on your machine, you probably didn't need that.
I know, I did.
Oh, you needed to run sudo on your machine? Oh, interesting. Okay, so in any case, after we add the socket, we have new client. This is my server. New client connected, added client to shared mem. So that's what we did right here. So inside the else, this is the parent's code. So if we're the child, then we're going to sit here and we're going to have a place for the user who just telnetted in to write something. We will first send them a little welcome message. That's what we received out here. We just said connected, right? Probably should have kicked that down a line, but whatever. Then when we read something in, we're just echoing it. Well, actually, we typed it in here, and then we're printing it out at the server instead of broadcasting it to everybody. So this is the from the client, the message they received from the server. All right, so that's this thing running initially. So now what we need to do is we need to have, when we type it to the client, instead of printing out to the screen on the server that the client has sent something, this guy needs to go and broadcast that message and send that information over all of the sockets on the server that are not this guy's socket. That make sense? All right, so rather than outputting here, what we're going to do is we're going to go through all of the things on the server. Now, connected clients, this guy is an integer, right? Now, when a particular client when a client connects and the server creates a child, That child gets their own copy of connected clients, right? What will connected clients have in it?
The amount of clients that were added when that child was created.
Yeah. And will it ever change? Will never change from that point forward. All right, so from that point forward, if you're trying to operate off of the number of connected clients, you'll never have access to the up-to-date number of connected clients. You'll always be looking through a subset of those. So what's a fix for that? Yeah, give us a second shared memory variable, right? So give us a pointer to that guy. So where's my shared memory stuff? And I think, do we need a second key for this? Or I think we need a second key. And I'm not even going to worry about the key. Do I need share memory ID after that? I don't think so. Pretty sure then after I have my first pointer, I can go ahead and I'm going to give myself a I'm going to copy these two lines. And I'm going to use I'm going to recreate a shared memory ID using the same key. Because I think the key doesn't have to do with what address it gives you. So I think we're okay with this. We'll test it in a second. Otherwise, we'll just create a different key. So I'll get some more shared memory, but I only need enough to hold a single integer. And we'll go ahead and create it. And then I'm going to create my connected clients there. And then we'll store in there a 0. All right, so at this point, my connected clients has now become a shared memory variable that starts off as 0. That makes sense? All right, so for right now, just to test this and, well, I guess we could just keep going. That's potentially a place we break if we should be able to do this. Print F. %p \n %p \n, and we will print out shared memory pointer as well as connected clients. And this is going to be on the server. We should see 2 different memory addresses if this gave us what we thought it should give us. Oh, I need to, down here, it's not just connected clients, it's star connected clients, right? All right, so then, okay, it looks like it is the same address. So, is it different? Oh, good. Then it looks like it worked. I was thinking I might have needed a second version of this key. Okay, so now, every single time we have a connected user, the connected clients number should go up, but because this is, and actually we need to do that, connected clients ++ to increment the value that lives there. That should go up, and that should be shared amongst all the children, right? Okay, so now we will come down here. So when a child receives a message, rather than just printing it out to the server screen, the local monitor here, we instead want to go through every bucket of our, what's it called, shared memory pointer, this guy. And the number of buckets that are in there is going to be connected clients. So we'll say int I for I is equal to 0. I is less than star connected clients I plus plus. And now we want to go ahead and send. We'll just broadcast to everybody right now. So we're going to send not to the new socket, but instead we're going to send to just steal this for a second. Shared memory pointer plus I. That's going to be a bucket in that array. So this is the socket ID, or this is the file descriptor for the connected socket that lives in that shared memory pointer. Okay? So we're going to send to the value that lives there, which is their pointer to our socket. What we're going to send is actually val red. String length of val red. So this guy should then broadcast to all connected clients, including themselves. That's what it should do right now. So go ahead. What? Boy, begun argument of int. Is this a warning?
It doesn't like the
String length of this guy.
no. The first argument in send, the shared memory pointer. Yeah, that's exactly what I had.
Oh, it expects that to be an int.
Yeah,
So you just have to typecast it to int. It's just a warning anyways.
that's it.
Let's see.
I think it's kind of already need to send buffer.
Val red tells us whether or not it was read in, correct? Isn't that right? Yeah. Val red was our error message, and whether this tells us how many bytes were read in. That's what val red returns. This is actually what got stored as we were printing that out last time. See, Annie, I was testing you. Not good. So let's see if this needs to be an int pointer. I wouldn't think it would need to be.
You may need to put your asterisk.
Oh, I still need that though. Oh, not there.
And you should probably change string length to be buffer.
Yeah. Okay. It's a who? Oh, sudo. Thank you. All right. I'm going to go ahead and connect with another client too. This is what connect with that guy, and we'll give myself one more. All right, 3 connected clients. We'll go to the first one. I'll go ahead and type in LOL. Not, it doesn't look like it changed. This says from client. Well, I'm still printing from client, but it's never actually getting sent to these. All right, so it is not connected clients is staying at 0. Did I actually finish setting that up? Yeah, there's the 3 times we added. I'm going to print out connected clients after each of those, proving it's changed, hopefully. It is not changing, still 0. So I wonder, do I need to say star connected clients is equal to star connected clients plus 1? Maybe plus plus, it's not defined. A little interesting, actually. Why is it 5, 6, and then 7?
You need to set it to 0 at the beginning. I had that problem too.
I thought I set it to 0.
It persists it's weird. Like it gives you the same chunk in memory between runs or something like that. I don't know, because I was up to like 28 when I was supposed to.
I see what you're saying. It's because we're not detaching from our shared memory.
Yeah.
We're killing it ourselves. So what we need to do is he just wants to move this down to where our server is initially listening, this guy. That way it always gets zeroed back out because we're not gracefully ending our program and actually detaching from shared memory. We're just falling from the sky and whatever was in shared memory is still there. Okay, so now this guy should be giving us better stuff. Okay, well, no, it's still 5, 6, 7. I did recompile it, didn't I? And I did save this. Zero. I'm going to print out connected clients right off the bat. Let's make sure it's getting that 0 value there. Okay, 0. Telnet, telnet, telnet. Oh, I keep zeroing it back out here in the while loop. So actually it's this. Otherwise I'm setting it back to 0 each time. Can
you go to work, scroll down, and I want to see what you're printing?
This is where I'm adding, well, I'm adding 1 to it. So we have an incoming connection, so this blocks. Then we're saying we have a new connected client. Then we're adding that client to our, well, adding our new socket at that bucket. And then we're saying connected clients is equal to connected clients plus 1. So that should go from a 0 to a 1. Then we're printing out the current value of connected clients. So here's the original 0 before we're listening. How did it jump to a 5? Oh, I bet. Here, let me kill these first. Shouldn't Control-C kill it? I wonder if these are trying to reconnect. Well, right, but that's what I've been doing. I don't think I still have it. So let me compile again here. All right, so it's at 0, and my port is 9012. That should have just gone to course 5. Why is that going to 5? Let me change that to %D instead of %I. I'm not sure why I was putting %I. That works in newer. Just want to make sure it's not something stupid like that. Okay.
I know last night on Slack you posted a fix for the SHM pointer that had us some people hard coded to 5.
Yeah, but I didn't do that in here. I want to try something here. I'm going to use a different key for my connected clients. I wonder if I'm stepping on. Yeah. Keys do need to be unique per shared memory. So I just added 1 to the key. So if you want to be generic.
That actually makes a lot of sense, because part of the reason I wanted you to scroll down to like look at what it's printing was I think that the socket numbers that we're going to be getting is going to be saying like 4, 5, 6, 7.
Yeah.
So then I think, or maybe it was 3, 4, 5, 6, and you were getting 4, 5, 6, 7.
So let's run this one more time. We'll connect
So it's working
here.
like 4. And that's what we said.
And then let me new terminal. That new terminal. There's that. Should be a 3 over here. It is. We'll type in LOL. Okay, we said sent 3 times. So we went in here the correct number of times, but we didn't actually send over the socket. So I'm thinking, do we need to flush the socket?
From what I saw online, it's the same issue, shared memory, the sockets aren't open unless they're open before you fork it. So any time you connect afterwards, it won't send. So basically, it won't send to any clients who are connected more recently than the client, that client is.
Than the original?
And so if you have 3 clients that are connected,
Yeah.
if the first one sends out, it won't send to the second 2 clients. If the third one sends, it'll go to both of you.
Oh, I understand what you're saying. So if I say LOL here,
Right.
the other guys get it because those first 2 clients were not
Because they were
these
like,
2 already knew about this guy knew about this guy.
mhm,
This guy knew about both of these guys,
Right.
but this guy only knew about himself.
Right.
So did he broadcast to himself? So he must not even know about himself.
he should know about himself.
It's not broadcasting to him.
That's weird.
He broadcasted to himself the first time, but we don't have it set up to read in multiple messages. It just reads in one and then it's done.
Yeah.
That's right, we only have a regular message right now.
Oh, I understand what you're saying. I just want to test that for the first client. Tell him that here. We don't have to do anything else. We'll say Woot. So I should see Woot a second time. Okay, it did broadcast to him. So he knows about himself. All right, so then we need to hold sockets open, or they do know about the address, right? Because they are
Yeah,
having.
I know about the address, but for whatever reason, they're not open.
What? This is gonna be. Do we need to make our sockets shared memory too?
Well,
Like, will they stay open if we actually store all the sockets? We're storing these integers related to the sockets in shared memory, but what if we make the sockets shared memory themselves?
that might work.
I had the same experience where I couldn't get it to broadcast to sockets after it was created.
Yeah, everybody online was saying to pass the socket through a socket to the processes.
Pass a
Do like send message. I think was the.
Oh.
Using,
another interprocess communication. Yeah, I get it.
yeah,
I
they're
get it.
saying you couldn't use shared memory really to do it, or at least not to do it efficiently.
Yeah, so let's try that since we're already in our shared memory world. So we're going to say int adder starts off at 0. So our first shared memory ID is going to be plus adder. We're already writing weird looking code, so we might as well just roll with this. And then this is plus adder plus plus. So now when we get our new socket, our new socket is not going to be defined there. Okay, instead, we're going to say int pointer new socket is equal to, actually we need shared memory ID first. Then let me do the shared memory get to steal this line. So we'll have new socket live in shared memory, except still add it to shared memory. Shouldn't have to do anything else now. Makes pointer. Oh, we need to say star, new memory. I'm lost. Or new socket, rather. Star new socket equals the result of that except. Where else do I say new socket? Star new socket. Star new socket. One more. Okay. Sudo. All right, so the test should be if we go to the first guy, type LOL, he should broadcast to the other ones. Does not. So throwing those guys in shared memory did not help either. I have a follow-up thing to test. Sudo that. I'm going to try to launch telnet as sudo to see if it's an access thing. Nope. So even though we have shared socket IDs, we probably could open a socket given an ID. I wouldn't have expected you to do that on the homework. C open socket given ID. Let's just say open socket. Like kind of asking the operating system for a socket that's already in existence. Okay, well then it looks like we're gonna have to look at another layer of inter-process communication, not just semaphores, because semaphores are gonna allow us to protect that central guy, but we're gonna need something else that allows us to, there's gotta be another solution for that. Is it something specific to sockets in multiple processes?
What does it look like? 'Cause a couple places I was looking
They were
at,
doing
back when they were
threads.
doing threads.
Okay, yeah, it would work with Pthreads. Next time, let's look at an example of Pthreads with this. Then we'll look at a message passing thing for sending information between two processes. Because those are two separate things. When you have a thread, you're actually operating within the current process. When you have multiple processes, they're separate entities, separate PCBs. So the issue here is that we have 4 different total PCBs that live in the system, and when a socket was created on one of them, the other ones don't know about it unless it was in existence beforehand. So it's whenever they interacted with the network infrastructure for the operating system, they only had access to the stuff that existed then, which seems weird. Why would it have access at all? But we'll try it with threads. I think threads will obviously work because we're not actually leaving the process. That way we'll see how threads work, and then we'll go from there. All right, I'll see everybody on Wednesday. Bible homework will be up sometime this afternoon. I probably won't have it due until midnight Sunday, though, since we have the hackathon on Saturday.